Hello, my name is Diego Patterson, and today I will be going over my research project for NLP, and this is context-aware speaker attribution in narrative fiction using natural language processing. So to start off, here's my purpose. The primary objective of this project is to develop a context-aware speaker attribution system that accurately identifies speakers in untagged narrative dialogue by leveraging Llama 3.2 with 4-bit quantization. The project aims to utilize surrounding narrative cues beyond simple dialogue tags to resolve speaker identity in complex texts like Agatha Christie's The Mysterious Affair of Styles. So the main reason I used this book was because I figured with a model, each character would have a distinct style and the dialogue spread would be better so that it wouldn't just be one person that overtakes all of the talking. However, as you'll see later, that did end up happening and we had a couple problems with that. So for my implementation, I utilized Llama 3.21b. I chose the 1 billion parameter version to balance performance with speed. To make the model more efficient, I applied 4-bit quantization. This reduces the memory requirement significantly without sacrificing the model's ability to understand the complex linguistic structures found in Project Dialogism novel corpus. Before running the final modules, I established these expected results. I set a target of 70% and for accuracy and F1 score between 0.65 and 80%. I chose these specific numbers for a few reasons. Since our baseline is 43 with just guessing period, a 70% target represents a significant move towards understanding rather than just picking one guy. Second, the F1 range of 65 to 80 is just standard for academic benchmark of good performance. My goal was to see if this 4-bit quantized Llama 3.2 could bridge that 25% gap by transforming raw narrative context into clear, separable numeric data. So the initial data that I had right here was this slide is just breaking down the linguistic complexity of our data set. At the top, you can see the raw totals, period, dominating the dialogue, which creates class imbalance that we have to manage later. The middle charts are important for my research. They show that a huge portion of the book consists of implicit and honorific quotes. Unlike explicit quotes that say, period said this, these rely entirely on surrounding narrative and context. Looking at the bottom chart, you can see that for characters like Hastings, the majority of his dialogue is untagged. This confirms that a simple keyword search for names isn't enough, and the model must understand the context to achieve high accuracy. So as we go and move on to our results right here, we'll start with model comparisons. This slide shows the final performance comparisons looking at our dummy classifier, which is our majority class, essentially is at R0. This proves that for the F1 score, it's essentially at 0. This proves that without context, the model has no baseline ability to guess correctly in these specific tests. The real success is the MLP unweighted model, which reached a 52% accuracy and a 0.41 F1 score. This is a massive improvement. Interestingly, when we tried to resample the data to fix character imbalance, the performance dropped significantly to 48%. This suggests that for this specific dataset, the raw distribution of how characters speak was actually a useful signal for the NLP to learn. With a 4-bit quantization, the Llama 3.2 model provided enough numeric detail for the MLP to efficiently separate these character voices. So this slide shows that the per character breakdown, and it highlights the reality of the class imbalance we discussed earlier. Looking at the confusion matrix, you can see that there's a strong diagonal line for period. This means that the model has successfully identified his numeric signature, achieving a recall value of over 80%. However, looking at the bar charts on the right, you'll notice that a significant drop-off was for secondary characters like Mary and Cynthia. These models frequently confuse these characters with each other. This suggests that the Llama 3.2 is excellent at picking up on period's unique dialect. It struggles with minor characters who have fewer dialogues and less distinct speaking styles. For a context-aware model, this indicates that the context for these characters might be too similar for the MLP to distinguish effectively. So to wrap this up, I am comparing my actual results against the goal set at the start of the project. Well, we achieved a significant jump over the baseline. We fell short of the 80% F1 or 0.8%, 0.8 F1 target, finishing at 0.41. Analyzing these comes down to 3 main factors. First is class imbalance, and the mysterious pair of styles was more severe than we expected, making it difficult for models to generalize across full casts. Second, the high frequency of implicit dialogue. Quotes with no tags at all require a level of narrative reasoning that might exceed over 1 billion. parameter model. Finally, this suggests some room for improvement. That is, essentially, we could have used more dialogue and we could have had a better spread and stuff like that. But the project successfully proves that the potential of context-aware attribution while defining the clearer technical struggles that still remain.